Welcome back, everybody. This is our video solution to Problem 2 from Quiz 4, Fall 2023, Math 307, Linear Algebra at Cal State Fullerton. In this problem, we are given a linear map from R2 to R3, and it's going to take an element of R2, say x, y, and it'll return 3x minus y, 0, x plus 2y, and we want to find a basis for the range of S. So let's briefly recall what the range is. So the range of a function is going to be all the possible outputs. And we see here from this defining property of the linear map S, the outputs all look like, well, this given form, 3x minus y, 0, x plus 2y. So the range of S is going to be all things of that form, 3x minus y, 0, x plus 2y, where here the x and y, since we're working over the real numbers, have to be in R. All right, well, let's just fiddle with this expression a little bit. So I notice here there's an x in the first and the third components. So if I pulled an x out of 3, 0, 1, okay, where am I getting that? Notice here it's 3x, 0 x's, and 1x. This would give me 3x plus, or 0, x. Well, it's not exactly what I want. I need some y's too. So let's pull a y out. I see that's in the first and third component as well. And so I'll put here -1, because this was negative y, 0, and 2, because we had 2y. And again, x and y are any real numbers. All right, and so what we see now is that the range of S can be written as a linear combination of these two vectors, 3, 0, 1 and -1, 0, 2. And so this is actually just the span of those two vectors. So the span of 3, 0, 1 and -1, 0, 2. Cool. We wanted a basis, and we already found a list that spans. So a basis, of course, remember, needs to span the space, but it also needs to be linearly independent. So we have to make sure that this list is linearly independent. If it's not, we'll have to remove something, and then we'll have a basis. Now, by the linear dependence lemma, so by LDL, in order for a list of size 2 to be linearly independent, I just have to make sure two things. Number one, the first vector isn't 0. So by LDL, this list is linearly independent since, okay, so first, 3, 0, 1 is not the 0 vector, 0, 0, 0. Okay, that's pretty evident. And 2, we need to make sure that -1, 0, 2 isn't in the span of 3, 0, 1. So, and -1, 0, 2 is not in the span of 3, 0, 1. Well, actually, how do I know that? Well, the span of 3, 0, 1 is all the multiples of 3, 0, 1. So this is all things of the form, well, just multiply by, well, how about x? It's all things of the form 3x, 0, x, where x is some real number. But if -1, 0, 2 was in this set, well, then that would mean -1 would equal 3x. Well, 0 would equal 0, that actually works, and 2 would equal x. But you cannot have these simultaneously true. If x is equal to 2, then 3x is equal to 6, not -1. So not possible. Okay, so this was working under the assumption that somehow -1, 0, 2 was in this span. It's not possible, so it is not in the span. And since neither the first vector is 0 nor the second is in the span of the original by LDL, the list is linearly independent. But since it's linearly independent and it spans the range, we know that it is a basis for the range. So therefore, this list 3, 0, 1, -1, 0, 2 is a basis for the range of S. And there we go. All right, everybody, we will see you next time.